All right, so we're going deep today into oil and gas exploration.
Hmm.
One of the things that always gets me is like how we figure out what's going on, like way deep underground.
Yeah, it is amazing, like putting together this
It's
puzzle.
like a puzzle. And speaking of puzzles, you sent over some research about this technique
For sure.
called
Yeah.
DFIT, Diagnostic Fracture Injection Test.
Yes.
And this is for characterizing reservoirs.
Yes. It's getting a lot of attention.
Yeah, so we're looking at a paper from the 2020 SBE Lebanon Offshore Oil and Gas Exploration and Development Symposium.
Okay.
Quite a mouthful there. But it's a comparison of DFIT and the traditional Minifrac test.
Right.
And it was written by some folks from Calda Petroleum Company in Egypt and Marietta College.
Oh,
I
wow.
thought that was really cool to have like the industry and the academic kind of perspectives in there.
Yeah, it definitely gives it some weight.
Yeah. Now, I know you might be thinking, why do I care about how they measure rocks underground?
Yeah.
But this stuff's important, right? Understanding these reservoir properties,
Yeah.
it helps predict how much oil we can get, how to get it out, and even how to lessen the impact on the environment.
Exactly.
So let's start with the way it's been done, the Minifrac.
Okay, so essentially, a minifrac is
Okay.
you're injecting a special fluid down into a wellbore to create a little fracture in the rock.
Okay.
And by looking at those pressure changes and how that fluid flows, we can learn something about the characteristics of the reservoir.
So like a stress test kind of for the rock.
Yeah, that's a really good way to put it. Yeah, like how it behaves under pressure.
So now comes DFIT. This is the new
Right.
the new approach.
The new kid on the block.
And it's like Minifrac. It also fractures the rock, but it does it using plain water.
Yeah.
And that's what has everybody interested.
It is. It really changes things up.
So what is it about the water?
Well, okay, so with water, you can measure different types of permeability
Oh,
as opposed to Minifrac, which gives you just kind of a limited view.
okay. And permeability, that's how easily fluids can flow through the rock, right? So
Exactly.
we're getting like a better view of the reservoir's, what'd you call it? Sponginess.
Exactly.
Yeah, okay.
And that's super important to know, like how much oil we can get and the best way to get it out.
So this is where it gets really cool, right? The paper talks about this thing called tortuosity.
Oh, yeah.
And at first, I thought it was like a Harry Potter spell or something.
Sounds like it.
But it's like how twisty, how complex the pathways are in the rock.
Oh, imagine like a maze inside the rock, all those twists and turns.
Oh, okay, so DFIT can actually map that out.
It can.
That's amazing.
Yeah, so it shows you where the flow might be more restricted, those high tortuosity areas,
Yeah.
versus places where oil and gas flow easily, low tortuosity.
So this is like we're getting a whole new understanding of how the oil moves in the reservoir.
Exactly. It's like having a roadmap of what's going on in there.
So we've got the theory, but how does DFIT perform out in the field? Right. The paper gives us 3 case studies
Yeah.
comparing DFIT with Minifrac. So let's take a look at those.
Okay.
In the first case study, it looks like they both kind of gave similar results, characterizing the reservoir.
Yeah, pretty much.
But even in that case, the paper suggests DFIT might be cheaper.
Yeah, because DFIT uses plain water. You're not using all these fancy fluids.
Oh, okay.
And that can save a lot of money, especially on big projects.
So round 1, maybe DFIT wins on points,
Yeah.
even if it was a draw on the data.
Yeah, I'd say so.
So case 2, what happened there?
This is where DFIT really stands out.
Okay.
The Minifrac just completely failed.
Oh, wow.
It didn't give any usable data.
Rabbit.
They think it was the complex geology.
No.
Minifrac just couldn't handle it.
Huh.
But DFIT, it managed to provide insights into permeability and reservoir pressure.
Okay.
Seems like it can handle the tougher situations.
So we're seeing a pattern here. DFIT holds its own, even outperforms in some cases. But before we get ahead of ourselves, let's see what case study 3 tells us.
Okay, so case study 3, it's a bit of a reality check.
Oh.
This was a depleted reservoir, very low pressure,
Okay.
and DFIT didn't do as well.
It's not a cure-all then.
No, it's not. The authors suggest that in these depleted reservoirs, the water just disappears too quickly.
Oh, okay.
It can't really measure the rock properties accurately.
So you need a certain amount of pressure for the test to work.
Yeah, that's right.
All right. So advantages for sure, but it's not a one-size-fits-all solution.
Definitely not.
So before we jump to part 2, let's recap what we've learned from these case studies. What stood out to you?
Well, it looks like DFIT really shines in those tough reservoirs where the traditional methods struggle.
Okay.
And even when they both give similar results, DFIT might be way cheaper because it uses plain water.
So we've seen how DFIT can handle tough situations and maybe even shake things up with its cost effectiveness. But what does this mean for the bigger picture? Could this lead to more efficient oil and gas extraction, maybe even with less environmental impact? We'll explore those questions and more when we come back for part 2 of our DFIT deep dive.
So yeah, this idea that DFIT could make oil and gas extraction better for the environment, that's really interesting.
It is, and it makes you wonder, if it works so well in sandstone,
Yeah.
could it be used for other types of rock formations too?
That's a great question, and a lot of researchers are looking into that right now.
Oh, yeah.
The basic idea behind DFIT, injecting fluid and seeing how the pressure reacts,
Yeah.
that applies to different rock types, but the details, that's where it gets tricky.
So it's not just a simple, like, swap it in, swap it out kind of thing.
Mm.
What are some of the challenges with, say, shale or carbonate rocks?
Well, those formations, they're just more complex.
Right.
Sandstone is pretty consistent,
Yeah.
but shale, for example, it can have all sorts of different properties,
Yeah.
even within a small area.
Oh, wow.
So it's hard to make sense of the pressure data.
It's like trying to read a book where every page is in a different language.
That's a perfect analogy. You need a much more sophisticated approach.
And what about the fluid itself? We've talked about how using plain water is a big advantage in sandstone.
Right.
Would that still be true for other formations?
That's another good point. Water might react differently with those rocks.
Okay.
It could mess with the pressure readings, give you wonky results. So researchers are testing different fluids or maybe adding stuff to the water to see what works best.
So it's about finding the right recipe, kind of, for each type of rock.
Exactly. It seems like there's still a lot of work to do before we can use DFIT everywhere.
Okay, but let's say it works out. What kind of impact could it have on the industry?
Well, for one, we could drill more efficiently.
Oh, wait.
If DFIT can pinpoint the best spots in a reservoir, we wouldn't need as many wells.
Yeah.
Less surface disturbance, lower costs, it's a win-win.
So better for the environment and better for the bottom line. I like that.
And we could also get more oil and gas out of each well.
Really?
Yeah, with a better understanding of the reservoir, we can optimize everything: placement, completion techniques.
So we're getting more, but we're also doing it more efficiently.
Right, and it also helps us manage the reservoir better.
Okay.
With more accurate data, we can control the pressure, the fluid flow, maybe even extend the life of the reservoir.
It's like we have a crystal ball showing us the future of the reservoir.
Kind of, yeah.
But before we get too carried away, what research still needs to be done to make all this happen?
Well, we need to test it in all sorts of different places.
Okay.
Get data from different formations to see if DFIT really works, and figure out how to adapt it for each type of rock.
So real-world testing is key.
Exactly, but it's not just about the data, it's what we do with it.
Okay.
We need better models, better algorithms to analyze that data, taking into account the unique features of each formation.
It's like having all the puzzle pieces, but needing a more advanced instruction manual to put it together.
Exactly. We need to make sure we're interpreting the data correctly.
Yeah.
And that requires understanding both the technology and the geology.
This makes me think, are there other innovations besides DFIT itself that could help us understand reservoirs even better?
Oh, absolutely. There's some really cool stuff in development.
Like what?
One thing is integrating DFIT with other technologies like microseismic monitoring.
Microseismic monitoring. What's that?
It's like listening to the earth.
Oh, wow.
We put sensors around the wellbore, and they pick up those tiny seismic waves that happen when we fracture the rock.
So we can actually hear the rock breaking.
Pretty much.
Yeah.
It gives us real-time info on how those fractures are growing.
Okay, so that's adding another layer of detail to our reservoir map.
Right, and then there's also advanced imaging techniques.
What, like 3D images of the reservoir?
Yeah, imagine an MRI for the Earth.
Wow.
You could see the fractures, how the fluids are distributed, even things like faults or other geological features.
So we're going from a 2D sketch to a high-def interactive model.
That's the idea, yeah.
That's incredible. How
Okay.
far off is all this?
Some of it's already being used, some is still in development.
Yeah.
But the pace of innovation is incredible, especially with the push for more sustainable energy.
It's amazing to think that DFIT was cutting edge just a few years ago, and now we're talking about combining it with all these other tools.
I know, it's really exciting.
What do you think is the biggest driver behind all this innovation?
I think it's the need for sustainable energy.
Okay.
We need to reduce our environmental impact, transition to cleaner energy, and that's pushing us to find better ways to extract oil and gas.
So it's not just about getting the resources, it's about doing it responsibly.
Exactly. We need to minimize our footprint and think about the long-term health of the planet.
We've covered a lot of ground in this part of our deep dive, looking at DFIT beyond sandstone and all these amazing new technologies.
It's been a lot.
But before we wrap up, we need to talk about the potential risks and challenges with DFIT.
That's a good point. We need to look at both sides.
So in part 3, we'll put on our skeptical hats and explore those risks, make sure we're not overlooking anything.
Sounds good.
Stay tuned for the final part of our DFIT deep dive. Okay, so welcome back for the final part of our deep dive into DFIT.
All right.
And in this part, we're kind of switching gears a bit.
Okay.
You know, we've talked about all the good stuff, the potential benefits, the exciting new tech.
Right.
But now we need to look at the flip side, the potential risks and challenges.
Yeah, that's important. Like with any powerful tool, you got to consider both sides.
So let's put on our skeptical hats, shall we?
Let's do it.
And dive into those potential risks.
Okay.
One thing that comes to mind right away is induced seismicity.
Yeah.
We've heard about that with fracking, right?
Right.
Injecting fluids can sometimes trigger earthquakes.
Yeah, it can happen.
So is that something we should be worried about with DFIT as well?
It's a good question, and it's a valid concern.
Okay.
DFIT does involve fracturing rock, and that can create seismic waves. But the key thing to remember is the amount of fluid we're injecting with DFIT is way less than with fracking.
So the earthquakes, if they happen, would probably be much smaller.
Exactly. The tremors from DFIT are usually tiny. You probably wouldn't even feel them at the surface.
Okay.
But even small tremors can be a problem if they're close to people or buildings.
Yeah, that makes sense.
So it all comes down to location, right?
Right.
And understanding the geology really well before we start injecting anything.
So we need to choose the location carefully and do our homework on the geology.
Absolutely. And we can also use technology to help us.
How so?
We can monitor for seismic activity, use sensors to track any tremors,
Okay.
and if we see something happening, we can adjust our operations.
So it's about being proactive and using tech to minimize the risk.
Exactly. That's the key.
What other potential risks should we be thinking about?
Well, there's also the risk of groundwater contamination.
Okay.
Even though DFIT uses plain water, there's always a chance of leaks or spills, especially if there's a problem with the wellbore.
I see. So even though water seems pretty harmless, we still have to be careful.
Right. We need to make sure the well is built properly and maintained well to prevent leaks.
Okay.
And we also need to monitor the groundwater regularly, just in case.
So it's about having multiple layers of protection, good well construction, monitoring, and a plan B if something goes wrong.
Exactly. We need to be prepared for anything.
This brings me to a bigger question that I've been thinking about.
Okay.
Even if we can prevent earthquakes and keep the groundwater clean,
Yeah.
aren't we still contributing to the environmental impact of fossil fuels just by extracting them?
That's a really important point, and you're right.
Okay.
No matter how efficient we get, there's always going to be some impact.
So DFIT isn't a magic solution. It's a tool that can help us reduce our impact, but it doesn't change the fact that we're still relying on fossil fuels.
That's a good way to put it. It's a step in the right direction.
Okay.
It can help us be more responsible, buy us some time as we transition to cleaner energy.
Yeah.
But it's not the end solution.
I appreciate that perspective. It's easy to get caught up in the excitement of new tech and forget about the bigger picture.
It is, for sure.
So for our listeners out there, what's the takeaway message here?
Well, I think DFIT shows us that technology can play a big role in the future of energy.
Okay.
It can make oil and gas extraction more efficient, less harmful, and maybe even help us transition to cleaner alternatives.
But we have to be realistic, right?
Yeah, we need to look at both the benefits and the limitations. Be critical.
And remember that technology is only part of the solution.
Exactly. We need good policies, regulations, and everyone working together to really solve these energy challenges.
Well said. I think we've given our listeners a lot to think about today.
Yeah, definitely.
We've gone deep into DFIT, the technical stuff, the potential, the risks, and how it all fits into the bigger energy picture.
It's been a great discussion.
And all our listeners, if you come across any interesting research on this topic or any other energy advancements,
Yeah.
send them our way.
Please do.
We love to explore. Until next time, keep those brains buzzing.